After gaining results from several pioneering joint industry projects working according to Zero Vision tool, now the Joint University Project 0.8's task is to assess and, when possible, validate socioeconomic benefits from them, and to establish a more safe, environmentally and energy-efficient transport at sea. Lessons learned from the joint industry projects working according to Zero Vision tool are that they need to be able to more concretely value the benefits. The additional cost incurred in building of a green vessel running on an alternative fuel is approximately 10 to 30% more than for a conventional run vessel. What is this additional investment worth for the society, climate and the sea? This project aims to calculate and verify the benefits such as human health improvements, climate change reductions and create job opportunities. This is needed to establish the full benefit circle, where shared knowledge takes industry, society and academy both faster and more initiated towards the joint interest aim of growth, welfare and climate improvements. The Joint University Project 0.8, comprising representatives from several universities and institutions, are therefore using existing models and developing new ones when needed to calculate and validate these soft benefits. 0.8 is monetizing these soft but so important initiatives.
If you know the value, then you can use your control mechanism to get the best benefit for the society.
0.8 has defined 6 perspectives from which the benefits are and will be calculated. The air perspective, where they calculate on emissions. The water perspective, discharging water. The modal shift, back shift perspective, an environmental and financial comparison between different modes of transport.
Because if you are calculating on, let's say, an electric train, you would find 0 emissions locally by the train or an electric car. But those emissions arises somewhere else where you generate electricity. And of course, if you compare different modes of traffic driven by combustion engines or by electric engines or motors, that means that you have to take into consideration the well-to-wheel approach.
Then you have the other impacts. It is the need of infrastructure, and there sea transport have a big advantage that the water is there. Maybe you need some deeper fairways, but this is not big investments compared to these billions that are invested in land-based infrastructure.
The safety-risk perspective. They compare safety and risk costs between different transport systems. The noise perspective. To compare noise impact between different transport types. And the perspective of environmental performance indicators. The need for comparative data on different environmental and climate improvement figures. Since models already exist to calculate emissions and have been used when sulfur regulations were discussed in 2009, the air perspective is the focus area that has come the furthest.
So we look at mainly at nitrogen oxides and particulate matter, but also on climate gases like carbon dioxide.
Calculations on all joint industry projects have been made. So far, the results show an average of over €1 million per ship and year.
I think the most important part is to take these numbers and start talk to the ones who are potential financiers of these types of ships, to figure out where in their analysis that numbers such as ours could come in and have an impact.
The team working with a water perspective has just started.
This project is in the borderland between natural science and social science, and it's definitely a challenge to bridge those two different types of culture. At the same time, it's really rewarding if we succeed.
The next step for Joint University Project 0.8 is to continue the calculations within the started areas and further investigate the monetized benefits within the other defined perspectives. All this is done in parallel to continued investments into the new, safer, greener shipping industry that gives back to nature, sea, health and society.